Welcome to the ET302 how-to video for the Ohm's Law 2 and Parallel Resistors lab. First part of this lab, we're going to figure out what resistance in our simple series circuit is. So we're going to use resistance equals voltage over current. So here in the first one, it's going to be 6 ohms because it's amps in volts, and then we're going to go in and measure the current. Here I am at Multisim, and I've uploaded the zip files from Canvas, and I've unzipped them so we can get a hold of the Multisim files. If you're using VMware, the files are going to be under the instructor files under 302. So let's go ahead and open up mine. I put it on the desktop. And I put it in Ohm's Law 2, and let's open up 10A. Good, and let's make it a little bigger. Okay, so first thing we need to do is turn it on. Make sure that we have the voltage on DC and the current on 2 amps. And let's go ahead. Right now we have 6 ohms into 12 volts, so we're going to get 2 amps. One user, it's going to be using the full amount of voltage. So let's turn it off, go into our resistor, and let's just change it to 1 ohm. Okay, let's turn it on again. Now we have 1 ohm into 12 volts is 12 amps. One user taking the full amount of voltage. 12 volts. So let's change this to K. So let's just go ahead and put a little K in there. And let's turn it back on. And now I have 1K into 12, which is 12 milliamps. Good. Still one user, 12 volts. So let's go back in, turn it off. And let's change this one to meg. Put a capital M in there. Okay. And let's see if we get a good reading. If not, we need to go into our meter here. So let's go ahead and turn it on. And this is not correct. So we're going to turn it off. And we're going to go to settings, and we're going to change our ammeter resistance to 1 ohm. And this should correct it. And now we have 12 microamps. So this is just an issue with the meter in the software. So that's how we changed the resistor sizes. And that's all. Here's part 1B of our lab, and we're going to do the same thing. We're going to figure out what the resistance is, but this time we're using milliamps. So 1 to 10 is going to be 10. But since it's milliamps, we are going to use K ohms. Okay? Okay, in part 1C, we're going to do the same thing. We're going to calculate for resistance, but this time our current's in microamps, which means our resistance is going to be in megohms. So we're going to have 20 large M megohms. And we need to make sure our meter's set up to read properly. So if we have a problem, we're going to go ahead and change it. Here in part 1D, what we're going to do is we're going to use Kirchhoff's law, and the total voltage is equal to the voltage of both the elements in this case, because we have 2 series resistors. So what I do is, since we have 20 volts, 5 volts, and 15, I could go ahead and use 5 ohms. And I could use 15 ohms. And we're going to be able to measure it, but since we're using ohms, our current is going to be in amps. Okay, I could also, in this case, I could use 2K ohms and 18K ohms. Still going to have the voltage distribution, but my current is going to be in 1 milliamp. Okay, and I could also do this. I could use 10 megohms, and I could use 10 megohms, and my current's going to be 1 microamp. Of course, we could use different values in here to make what voltage we want, but this is the simplest method. Okay, let's turn off our last file and let's go to the new one, and we're going to open up B. And let's make it larger. And here we have 2 resistors, 10Ks and a 20. So when we start this, let's go ahead and up. Since we're in K, we're going to get milliamp. And we have 10 volts and 10 volts. So we have 20 volts, 2 users at 10 volts each. They balance out. So let's go ahead and do 15 and 20, or 15 and 5 to make 20. Restart, and we have 15 volts and 5 volts. 15 plus 5 equals 20. So we're sharing that voltage of our battery, and we're at 1 milliamp, pretty close. Okay, here we're going to calculate parallel resistors, and we could break out our calculator and do these equations, or follow my basic simple rule is when we have multiples of the same size resistor, just divide it by the number of resistors. So we have 1 ohm divided by 2 resistors, so our resistance is going to be 0.5 ohms. Here we have 1 resistor of 2 ohms, or 2 resistors of 2 ohms. 2 divided by 2 is going to be 1 ohm, and it's that simple. Okay, let's turn this off and go open up our parallel files. We don't need to save it. And let's go back to our desktop. And we're going to go to parallel resistors, start with 6A. And here we have 2 parallel resistors. And let's start it. Open up our ohm meter. And we have 5.5 ohms. 1 divided by 2 resistors is a half. So let's go ahead and just try 6. And turn it on, and we have 3. 6 divided by 2 resistors, 3 ohms. That's perfect. Here we need to figure out 3 parallel resistors. So the rule still applies. So 1 ohm divided by 3 resistors is 0.333. Since it's in K ohms, we're going to leave it in K ohms. And the same applies for the rest. Here I've inserted a ammeter, and we're going to do some Ohm's law and some measurements of our parallels. So let's just do the last one since it's simple math. So we got 3 6s. So the total resistance is going to be 6 divided by 3 is going to be 2K ohms. Okay, and we have 12 volts. We're starting with 12 volts. So our total current calculated is going to be 6 milliamps. K's go to millis. So, and let's go ahead and measure that. Okay, so let's go ahead and open up our last file. And we're going to use circuit 6C. And what we have here is 1K. So let's go ahead and just match our things. So let's go ahead and make these 6K. Open up our ammeter, turn it on, and we have 3 6s, so 6K divided by 3 resistors is 2K. 2K into 12 volts is 6 milliamps. Perfect.